students. My name is Pankaj and welcome to my channel Maths with Pankaj sir. Today we are going to learn transformation of functions. This is an important topic in AS Pure Maths. So we will be understanding each and every transformation from translation to reflection. So let us start the topic, and after this video I will upload one more video of past year question solving of complete chapter, which is chapter 2 functions. So you will get all the questions of transformation of functions in the chapter itself. So let's start the topic. There are three types of transformation that we are going to study. First one is translation, then we have stretching, and reflection. So we have translation and stretching both in x and y directions, and reflection about x-axis or y-axis. So first we have to understand translation, then we will understand stretching, and at last we will see reflection about x and y-axis. So let's go to the next slide, translation about x-axis. So now let us understand translation in x direction. The graph of y equals to fx minus a is translation of the graph y equals to fx by the vector a 0. So in the graph itself you can see that we are given y equals to x square minus 2x plus 1. If I want to translate this graph in the x direction with the translation vector, this is translation vector, so from the next time I will be using translation TB only. This is translation vector abbreviation. So if you are given translation vector which is let's say 3 0, this signifies that 3 units of translation in positive x direction. This also means that each value of x on the graph or on the curve is increased by 3, is increased, or you can say curve is better option. I will write curve itself. So on the curve is increased by plus 3. So you can see the graph of y equals to x square minus 2x plus 1 with in blue color. And if I translate this graph in positive x direction by 3 units, so I will get graph in red color. So whenever I have to translate a graph with a vector a comma 0, I will substitute x with x minus a. So for example, if I have to translate this graph with the translation vector 3 0, so I will have to replace wait, so for this I will have to replace x with x minus 3. And in case if the translation vector is given as -2 0, I will replace each value of x in the function with x plus 2, with x plus 2. So if translation vector is -2 0, I will replace x with x plus 2, and if translation vector is 3 0, then I will replace x with x minus 3. So now my function becomes y equals to x minus 3 whole square minus 2 x minus 3 plus 1. So wherever I had x in the original equation, I replaced it with x minus 3. Let's understand this with another example. Let's say if I have a function y equals to sine 3x plus 5x, and the translation vector is again -2 0. So now the graph after translation will be y equals to sine 3x plus 2 plus 5x plus 2. So I have replaced x in the original equation with x plus 2, x plus 2. So this is what we have to do in translation in the x direction. Always translation in x direction is always performed first. Star mark it. Translation in x direction, let me box it. Translation in x direction is always performed in first step. Always first, and translation in y direction is always at last. So y direction translation is last. Y direction translation is last. Let's move to the next slide, translation in y direction. So we have to understand, we are given, if we are given y equals to fx, then y equals to fx plus a is translation of the graph y equals to fx by the vector 0 a. To understand this, let's say we are given a graph y equals to x square minus 2x plus 1, and this graph is represented by a blue line. So this is y equals to x square minus 2x plus 1. Now, if I am given a translation vector, if I am given a translation vector of 0 and 3, 0a. So whenever there is translation in y direction, we add that particular value to the function y equals to fx. So y equals to fx plus a, this is translation in y direction. So fx is our original function. This is our original function, which is drawn by the blue color, and red color we are having graph of the translated original curve. So In this question, fx is x square minus 2x plus 1. So if the translation is in y direction, you will add that particular value as it is. You will add that particular value, I'm saying as it is. If it is 3, you will not write minus 3 as in case of translation in x direction. You will add the value as it is. For example, if it is 3, so you will add 3 to this original function fx as it is plus 3. And now this function becomes x square minus 2x 1 plus 3 4. This is my new graph. This is my translated curve, and this is represented by red color. This is the translated curve which I am highlighting. So this is translated curve y equals to x square minus 2x plus 4. Now let us understand this with a new question, the same question that we have taken in the previous translation in x direction. If fx is a sine 5x plus 3x and translation vector is again 0 comma minus 2, therefore equation of the curve after translation will be, so y equals to fx plus a here is minus 2, so this is our a. In previous question this was a. This becomes sine of 5x plus 3x, and this whole function is subtracted by 2. You will write that particular value as it is, so minus 2 plus of a means plus of minus 2, so it becomes original function minus 2. So now my translated curve is y equals to sine 5x plus 3x minus. So this translation in y direction in case of questions cross topic transformations, so cross transformations, you will do translation in y direction at the end and you will do translation in x direction at first. Let's move to the next slide. Transformation of functions, translation in x and y directions together. So if I have to translate a graph in x and y directions together, then we will understand it with the example. Let's say we have again a function x square minus 2x plus 3. We have to translate this graph with a translation vector which is 3 and minus 2. So this indicates 3 units of translation x direction, and this indicates 2 units of translation in negative y direction. Similarly, in the previous question as well, minus 2 indicates, this indicates wait, 2 units of translation in negative y direction. So for x, translation in x direction, I will replace x with x minus 3. I will do translation in x direction first, and at the end I will add minus 2 to the complete function. So the function becomes fx minus 3 plus 2. Fx minus 3 plus 2. So I will write this function as y equals to, first I will do translation in x direction, x minus 3 whole square minus 2 of x minus 3 plus 3, and for translation in y direction, this is my function after translation in x direction. I will add minus 2 in the function, so which will become fx minus 2. So my function is now x minus 3 whole square 2x minus 3 plus 3 minus 2, which is 1. So this is my graph after translation in x and y direction with translation vector 3 minus 2. Let's move to the next slide. Stretching in x direction. So the graph of y equals to fx, f of ax is stretch of the graph y equals to fx with a stretch factor of 1 by a parallel to x-axis. See, in this graph we can directly say that if I am stretching a graph in x direction, stretching in x direction, then definitely one thing is sure, I am going to replace x as I have done in translation. So I will replace x with, this is important, I will replace x with what? I will replace x with x upon stretch factor. I will replace x with x upon stretch factor in the original equation. See, in this question, the original equation given to us is y equals to x square minus 2x minus 3. So this is the original equation which is given to us. This is the original equation, y equals to x square minus 2x plus 3. And if I have to transform this with a stretch factor in x direction, SF stands for stretch factor, always remember. This is so stretch factor in x direction, which is given to be 1 by 2. So if your stretch factor is 1 by 2, then how you will transform this graph? As I have already told you, this is very much important. You have to replace x with x upon stretch factor. Please note it down or star mark it. if you have to replace x with x upon stretch factor, now in this particular question you will replace x with x upon stretch factor, which is 1 by 2, which finally becomes 2x. So now you are going to replace x with 2x. So after stretching, the graph becomes 2x whole square minus 2 of 2x minus 3. Please do not commit mistake of writing y equals to 2x square minus 2 of 2x minus 3. So this is very silly mistake which students used to commit a lot. 2x square, they write 2x square in place of 2x whole square. So please avoid this mistake. So this is wrong, and this is right transformation. Now similarly, if I ask you in another question, I have example 2. If y equals to sine 3x plus 5x is transformed with stretch factor in x direction equal to 2. So understand, x will be replaced with x upon stretch factor, which is x by 2. So I will replace all the x with x by 2. Now my graph after transformation will be y equals to sine 3 x by 2 plus 5 x by 2. So this is my final answer. I hope you have understood the concept. Let's move to stretching in y direction. The graph of y equals to afx is a stretch of the graph y equals to fx with a stretch factor a parallel to the y-axis. So let us directly go to the example, or let me explain. If you are given a function y equals to fx and you have to stretch this in the y direction with the stretch factor in y direction equal to a, with the stretch factor in y direction equal to a, what I will do is I will multiply the whole function. My graph after transformation will be, I will multiply the complete function with stretch factor. I will multiply the complete function with stretch factor in y direction. Similar to what I did in translation. In translation also I added the translation units or translation vector value to the whole function. So same I will do for stretching as well. In stretching also I will multiply the stretch factor to the function itself. So as an example, let us understand. For example, we are given a function y equals to x square minus 2x minus 3, which is the original function. And now I want to stretch this in y direction. I want to stretch this in y direction with the stretch factor given to be 2. So my graph after the transformation will be whole function multiplied by the stretch factor. So I will write 2 into stretch factor into whole function x square minus 2x minus 3. So this is my graph after the transformation. and my final answer. Let us understand this with another example. Example 2. This is example 2. Again we have y equals to sine 3x minus 5x this time, and stretch factor is 1 by 3 in y direction. So my graph after transformation will be stretch factor multiplied by the complete function. So 1 by 3 is the stretch factor in y direction, and multiplied by complete function. So this is my final curve after the transformation. Let's move to the next transformation. Reflection in x direction. So this particular type of transformation is important, which is reflection. So we will understand it with the plane, with the graph, xy graph. Let's say we have a point in the first quadrant, and the coordinates of the point are x and y. This is x-axis, this is y-axis. Now I have to find reflection of this particular point about the x-axis. So reflection of this particular point in the x-axis will be somewhere here in the fourth quadrant, which is x comma minus y. So I will write now a note when there is reflection, when there is reflection in या फिर about x axis, then y becomes minus y. This is important. Y becomes minus y. When there is reflection about x axis, then y becomes minus y. This is something to note. Let us understand this with an example. For example, we have a original curve as given in the graph on the left hand side, right hand side actually. Y equals to x square minus 2x plus 1. This is the curve which is given to us, and this is the curve y equals to x square minus 2x plus 1. We want to reflect this curve about x-axis, or reflection in x direction. We want to find. Now, whenever there is reflection about x-axis or reflection in x direction, I replace y with minus y. So I will have to multiply the complete function with minus 1. I will have to multiply or find negative of the function. So the graph after reflection in x direction will be minus 1 into the function, original function x square minus 2x plus 1, and now the graph becomes minus of x square plus 2x plus 1. sorry, minus minus plus, and minus plus minus. So this is my graph after reflection in x direction. So this is graph after transformation. Now let us understand this with the same example, another example. Y equals to sine 3x and 5x. Find reflection in x direction, a reflection about x axis. So y equals to minus 1 into the original function, sine 3x plus 5x. So basically it becomes minus of sine 3x plus 5x, sorry, minus 5x. Let us move to reflection about y-axis. So we will understand this as well with the xy plane. Again, if we have a point in the first quadrant x comma y, and if I want to find the reflection of this point about y-axis, so I will have a point here which will be minus of x and y. This is x-axis, this is y-axis. So now something to note. When there is reflection about y-axis, then x becomes minus x. X becomes minus x, or you can also say replace x with minus x. This is important. This is important. So let us understand this with an example. For example, we have a function y equals to x square minus 2x plus 1, and I want a reflection of this graph about y-axis. Then I will replace after reflection in y-axis, x becomes minus x. So I will directly write y equals to minus x square minus 2 of minus x plus 1, which is x square 2x plus 1. So this is my graph after reflection in y direction. So I hope you understood the concept of transformation. There were three types of transformations: translation, stretching, and reflection, both in x and y directions. we have understood that whenever there is translation or stretching in x direction, so we will replace x with x minus a and with x upon stretch factor respectively. And whenever there is translation and stretching in y direction, then we will replace we will add the value of a to the whole function, and we will multiply the stretch factor with the complete function respectively. And when it comes to reflection, so for reflection about x-axis, y becomes minus y, and for reflection about y-axis, x become minus x. So this is done for today. I'm going to solve functions PYQs and coordinate geometry PYQs in the upcoming videos. So see you in the next video. Thank you so much.